Welcome. Hello, everyone, and welcome. I'm the team leader. My name is Snow Liu. I'm a mechanical and aerospace engineering master's student. I'm here with my 4 team members.
Hello, everyone. My name is Bernardo Perez. I'm a master's in mechanical and aerospace engineering student.
Hello, everyone. My name is Kai Wei. My major is mechanical and aerospace engineering.
I'm Angad Singh, and my major is electrical engineering.
I'm Haosung Wang, and my major is biomedical engineering.
And together, we are here to share some information about our capstone project, the compact breathing device. Upon meeting our sponsor, Dr. Sean Young, we were introduced to the project idea of developing a deep breathing device. We conducted initial research and found that people benefited from deep breathing both physiologically and mentally. A variety of deep breathing techniques are available, and they are very simple and quick to implement. In order to better understand the process and benefits of deep breathing, the team incorporated these practices into our daily activities. Shortly after, we were able to see the benefits firsthand. Our goal is to design, build, and test a device to encourage deep breathing. Before we share more information regarding our project, I have to address the confidentiality of our product. The team worked together and created 21 different designs and iterations. For feasible designs, we conducted simulations, prototyping, and product testing. However, due to confidentiality and proprietary nature of the materials used for filing patents, and based on the request of the sponsor, none of this information will be disclosed in the poster and video.
Well, there are many benefits of deep breathing. Firstly, it could trigger the calm response and help people to fall asleep faster. Secondly, it could boost the immune system and the digestive system. And it also could lower blood pressure and heart rate, and it could make people more immersed and focused when doing things. Last but not least, it allows people to relieve stress and reset state of mind.
Here we have our project budget and the projected production cost for our final prototype. Our largest cost was buying 2 spools of PLA filament to be used for 3D printing our prototypes. Other costs include the wind sensor for testing, an Arduino to drive the wind sensor, origami paper, cotton pads, and springs. Our total cost came out to be around $116 for the final prototype. We contacted a plastic injection mold manufacturer to estimate the price per unit cost. Using a $14,000 mold and polypropylene injection plastic for the body of the device, we found that it would cost about $142 per unit for 100 units. It would cost about $15 for 1,000 units and around $7 for 2,500 units. As we get into manufacturing multiple thousands of devices, the price per unit remains about the same at around $3 per unit.
As part of the testing and tuning process for our prototypes, we measured the airflow velocity to see whether the values fell within a range of 2 to 10 meters per second, which is the typical air velocity range during inhalation, and to see whether it would be able to achieve a volume flow rate of 440 milliliters per second or more. We connected an Arduino microcontroller to a modern device RevP wind sensor to put inside the prototype in order to log the airflow velocity during a 6-second 2-step inhalation process. The plot shown here shows the airflow velocity ranges achieved during the shallow and deep inhale. In both regions, the air velocities are within our desired range, and the peak airflow based off the prototype dimensions was 1,120 milliliters per second.
Here is our project timeline. We split our project into 2 separate parts, which are Series 1 and Series 2. In the winter quarter from January 12th to March 17th, we focused on designing and prototyping Series 1. We spent a lot of time for Series 2. From March 9th to the end of the spring quarter, we focused on designing, prototyping, and testing it. We began to do the airflow test at April 6th, and we started to design paper spring at April 12th using origami paper because we couldn't find a sealer that met our specifications.
Thank you for listening. We would like to also take this opportunity to thank Dr. Sean Young and Dr. Farzar Alman Conley for their support.